Hello friends, welcome back to another episode on Databricks. So this session will talk about Delta Lake, its features, how we can implement Delta Lake and also the performance. So before going in depth of Delta Lake, let me introduce what exactly Delta Lake. So it's an open source storage layer that brings reliability to data lakes. So Delta Lake is implemented by the founders of Databricks, and we know that the founders of Databricks are the founders of Spark. They donated to Apache Foundation, and now Delta Lake is an open service. You don't need to buy Delta Lake separately if you are using Databricks. It's inbuilt in Databricks. So the reason for implementing Delta Lake is to analyze the data and make sure that the data lake is acting as traditional database to some extent using Delta Lake. Before Delta Lake, we were using Hive tables to do any kind of analysis, but Delta Lake provided much more facilities, features compared to Hive. So we can talk about that in the later part of this video. And another important thing happened is with the help of Delta Lake, we can get rid of the complex Lambda architecture. Before Delta Lake, if you want to combine streaming and batch, it's a separate pipeline. But with the help of Delta Lake, we can combine streaming and batch into the same pipeline. So as you can see in the slide, we can store the data as it is from the source systems, that is nothing but ingestion tables. Then the next step that we do in data engineering is cleansing the data and store in the refined tables by applying the business logic, right? Then we can move that data into different mark. So these are the same thing that we do it in the traditional database too. So I want to say here that we can, with the help of Delta Lake, we can do most of the transactions action that do in the database, traditional database here in Delta Lake too. So these are the features provided by Databricks. We'll see how this will help us in implementing data engineering or analytics or data science activities. So the first feature is ACID transaction. So ACID transaction is very old concept in a traditional databases, right? So Databricks brings that ACID transaction here, which helps Databricks act as a database. So atomicity, whether all the changes happened or revert everything. Consistency is whatever the changes happening in the session, it should be available in all the sessions. The next is isolation. Isolation is very important in case of multiple users accessing the same object. So all the transactions are isolated from one another. The next is durability. It means whatever the changes happen, it should be permanent. The next feature is scalable metadata handling. We know that in big data we have a lot of files coming in every day. So that itself is like a big data. Databricks can handle this much of metadata very elegantly. They also provided time travel. So normally if you want to go back to the previous insert or previous update, it's very easy in Databricks. We can use the timestamp or version system and we can go back to the previous update or insert. This helps us to recover in case of any mistake happened very quickly. And as I said before, it's a unified batch and streaming source and sync. It means we can use this batch as well as streaming for the same source and sync. Schema enforcement. So in the database, what happens is it always check what's the incoming data, what kind of data type it is, and if there is any mismatch, it will reject the entry. The same concept applied here. Schema evolution. So it means in the big data, we have files coming in every day, and there may be high chance that the files may add new fields or remove the fields. So Deltabricks easily handle this. You don't need to do any extra complex program or any other activities. And it's also 100% compatible with all the Spark API, meaning the Deltabricks is exposed to Scala, Python, Spark SQL, all the APIs. Now we look into the performance, which is very important, right? So to understand the performance, what I did is I took the same table that we were using, a high table with a 20 billion record. I created delta table with the same metadata and loaded all the 20 billion records. Then fired the query, the same query, both in Hive table as well as delta table. And I got 30% improvement over Hive table. So this is the theory part. Now let's go to the demo, how we can implement all these theories that we discussed. We'll look into that. Okay, so now is the demo time. So we'll create the table, delta table, then we'll see how we can append the records, observe the record, also see how we can fetch the data from history. And we also talk about the optimization, right? So for creating the delta table, I created separate folder. So delta is the folder name, and I'm going to pull license data, right? So I created another folder license. Let's execute this. So there is no file in it right now, and I'll be using business, legally operating business, which I used in my previous demo too. So I know the data types and the columns coming in. So I provided the schema upfront and reading the data from the same location. And I know the CSV file is having header, so I made it as true and also provided the schema, right? So it contains license number, license type, expiration date, status, etc. Now it's a time to save the data in a delta format. So as I said before, the only change here is format. Instead of Parquet format, I'm using delta. Once you execute this one, we can go back to the folder and see what are the different files and folders created for delta, right? So it's completed. Let's go back here and execute this one. Now you can see one Parquet format, Parquet file is created under license folder, and also there is a delta log folder. We'll go inside and see what exactly it is, right? So it contains two files, one is .crc and one is .json. So you can compare this delta log as a transaction log file in our traditional database. So this delta log capture each and every actions happening on the delta link. With the help of delta log files, Deltabricks is able to capture the history, right? We'll see how it is happening. Now, next, what we can do, we create the table. Right now, we didn't create the table, right? But even without table, we can fetch the data by using delta dot the path, full path. So when you say delta dot, it go and check the metadata stored in the underscore delta log folder. So let's see what kind of data it is bringing. It bring all the data. So just want to show you, right? The same kind of data. Now we'll create the table. So if you look at two way we can create the table. One is create table name using delta. You don't need to provide the fields. The second method is you can give the field name. You can provide the data type, everything. So both the method is fine. So right now I'm using the first method. Now we'll go back and see what happened to that folder, right? So first let me go to the license, Control X, and execute this. So here there is no change. We'll go back and do some kind of data manipulation. Let's check this one. This is the select statement where we are pulling only this license number, right? Now we'll update the same license number. The status you can look at, this is inactive right now. I'm going to update. So if you look at Hive table, we don't have this option to update, right? But here in Delta Lake, we have update statement. So once do the update, what happens into the log file? That it's important, right? I'll explain what is the change it's happening there. Let's go there and see. Yeah, now you can see only two files are there, right? Let's execute. Now what happened? There are four files. So when you do update, what exactly happening is it's taking the existing file, do the update and store it in another file. It's not the same file. So if you go back to this license table folder, what happens? You can see separate file, right? We didn't insert any record. We didn't pull any data from different file. It's the same file. Only thing what we have done is update the record. But then how two files came here? That's the question, right? The thing is, Deltabricks will not update existing file. Instead, it create another file and apply the changes there. This is required because if you want to go back, think about the historical records, right? If you want to go back to the previous session, what it will do, it will go to the delta log first and see which version it is referring. Based on the referred version, it will pick this one or this one, right? So let's go back to here. That's the reason we can see four files there. For each Parquet file, we have two files here. One is CRC and one is JSON. So this is the latest one, right? So when you use historical version, based on the version, it will check what file it is referred here. Then it will pick the data from there, right? That's what it happens. Now what we'll do, instead of inserting, let's go back and instead of update, let's go back and insert record. So for that, I use the same license number. The only change I did is I added JIT into the license number instead of DCA. Right now we are not updating, we are inserting it. Let's go and insert it. Okay, now the insert is over. Let's go back to our place. Now you can see how many files for 2 CRC, 2 JSON. Now execute it again. Now you can see total 6 files. Another 2 file came for the latest insert record. Right now, how many files will be there in license location? There are 3. So this is the latest insert, this is the update, and this is the initial one. Okay, so next is we'll see how we can delete it. I'm going to delete the same license number that we inserted now, right? Delete. So this option also not there in Hive table, the delete, meaning the specific records, right? So here we have this option. Now we'll go back and see what happened to our log file, and also here in the license table. So it created another file. So in this case, what happens is it's the same kind of process happening at the time of update, right? It will not touch the actual file. It create another file and add one more file in the log file so that it can refer back which version it got deleted and which version it is available. So here you can see there are 8 files. So this is how Databricks works. This is how it maintains all the transaction logs and ACID properties. Everything is based on this delta log file, right? Now if you want to go back and so what happens if you don't want to keep the history for long? You know that if you keep the history, even the file size also will increase, right? If whenever you do update or insert statement. So you can make sure that even certain point of time you can purge the history records. You don't need to keep it, for example, 1 month or 2 month, 3 month. So what happens in traditional database, we take the backup and purge the transaction log. So similar kind of options you can do here. What we can do, we can just remove the history, right? So for that we can use vacuum. If you use vacuum, what happens is it will remove all the files that is not used by Delta Lake table. So to give the demo, what I need to do, so by default it keeps 7 days of history, right? If you want to change that, even if you do vacuum, it will remove all the files older than 7 days. But for this demo, I just created, updated, deleted right now. Not even 1 day, not even 1 hour, right? So to change that, to change the property, default property, we need to execute this option, meaning retention duration check enabled equal to false. So it will not check any duration, set duration while cleaning up the file. Then what you can do, you just do the vacuum, retain 0 hours. It means it will not check when the file came in or when the update or insert happened. It will remove all the files related to uh, any kind of update. Okay, before doing that, let me also show you how we can use the history, right? Because if I vacuum the files, then you'll not be able to see the history. So for that, let's do this one. How you can see the history? You can use describe and describe the history of the license delta table, right? And we can see what happened. So we have this much of thing happened. Let me do this. Yeah, so 0 version is the original version, and the first version we did update. Then second version we did insert, one entry we inserted, and the third one is the delete statement, right? So if you want to use any um, particular version to see, you can do like this. So syntax is very simple. You can select start from the table, timestamp as of. So you can see timestamp as of this particular timestamp, right? So here we updated. You can see that we did this value as an insert, not update. So even if you execute the query, you will not get any result, right? But at the same time, if you use the third one entry here, you will get the same result. I mean, you will get the result back, right? So this is how you can make use of the history. Either you can use timestamp or you can use the version as of to, right? So you'll get all the data. I'm not giving any filter condition here. So whatever the data came in as part of version 2, everything will be appearing here. And this is the another merge statement that you can use. Merge into the table name as a target. I'm using this I'm using the same table for now because I didn't create any other data to showcase, but no need to worry. Instead of license data, if you have any other staging table, you can use the staging table, right? So for that, what I did is I used as of version 2. So it's nothing but this is how you can use the history to update back also, right? So target license number equal to src license number. Let's go back and see what I'll do. Okay, so we updated the status as active, right? Yeah, for no, yeah, for this one, let's see what's the right value right now. Where's the select statement? I don't have select statement for this. Okay, let me see what's the status here. Okay, where the table is this. Now the status is active, right? What I'll do for doing the merge activity, I'm giving as of version 0, right? So in the 0 version, status is inactive, right? So what I'll do here, I'll just keep it as src status, right? And let's execute this. So once it is updated, we can go back and fire the same query and see what happened to that same record. Where it is select statement. Okay, so here it is active right now, and I did the merge statement. See, now it is inactive. So what happens is it picked the go back to the merge statement, right? Yeah. So here I took the first version and updated only for this license number with what I updated. If we find the match, then updating the status. So active status become inactive status. This is how you can use even the historical records to update back, right? So it's very easy to use, right? So you understood how you can do upsert, insert, delete, merge, and also seen what's happening behind the scene. Now let's go back and use this vacuum as I explained you before. So once you do this vacuum, we'll see what is happening, right? Okay, so the vacuum is done, and let's see history. Okay, so history is same, and we'll see whether we will be able to fetch the data. It says that there is no file because we vacuumed it. We are seeing we are trying to fetch the data for timestamp as of this one, but previously it was throwing error, I mean throwing the result, but now it is error because we cleaned up the data, right? Let's go back and see how many files are there in our license folder. So what happened, it reduced only 2 files. The first one is actually uh, the main file where the insert is happened, the last merge statement, it will be there. And this is the insert is separate file, right? So you can see the size. Oh, this is the insert statement 2737, and this one is the last merge statement file. So we have only two files. Now we'll go back to delta lock and see what happened there. Okay, so here it contains all the changes what's happened. Delete, insert, update, merge, everything is stored here. It's nothing happened here, right? And what I need to show you another thing is, we know that if multiple files are there when we insert, that will degrade the performance, right? So the optimal the size for each file is between 300 MB to 500 600 MB, and I think with the Delta Lake, they Spark 3 implementation, I think even they are okay to keep 1 GB. But if you look at the files that we created, the size is very small. So what normally do, we can optimize the files. So once you do optimize, what happens is all the small files that will club into one big file, right? So let's do that. So we'll see what happened to this once you do optimize. So we have seen that there are two files right now, and if you do this optimize, right? Okay, now you can see, you can here the statistics, you can see number of files removed, one file got removed and two files added, right? Sorry, number of files removed is 2 and the file added is 1, right? Now go back and see what happened to that. In the same license folder, okay, there are 3 files, right? Check the size. So this is 522.854, 522.854.2734. Now what I'll do, I'll go and do the vacuum again. Let's go back and do the vacuum and see what happened to that. Okay. Okay, vacuum is done. Now execute this portion again. Look at this. Now only one file is there, right? So when you did optimize, what happens is it took the big file and the small file and combined into another file and stored as a separate file. And when you do the vacuum, what happened? The files not associated with Delta Lake got removed, right? So these are the different options available in Delta Lake, and I want to show these different features in this session, and I'll come back with the more Delta Lake features in coming section. Till then, bye. If you would like to receive more such videos, please like and subscribe to my channel. Also, if you would like to connect with me, I have provided my details here, my email and LinkedIn. So thank you very much.